So now see here. The semantic network representation is in fact represented by two nodes and an arc. So arc means maybe, so if you see here, we have one node here and another node here. And maybe this sign is, this is the arc, right? This is a, arc means a line. And now let's continue to the next question here. Artificial intelligence mainly includes three university schools. So they are symbolism, connectionism, and behaviorism. Okay, symbolism, connectionism, and behaviorism. So symbolism represents, we just represent some real life problems with mathematical or logic, right? With mathematical function or logic. As you know, we already learned first order logic, and we can also represent some real life problems using math, right? So the first university, that is symbolism. So here we discuss mathematical and logical function. And the second one will be connectionism, okay? We connect them. And then the third one will be behaviorism. So behaviorism is also related to cybernetics, okay? So we got the three university, that is symbolism, connectionism, and behaviorism. Okay?
Okay.
And next one, if P is true and Q is false, the logical value of P implies Q is dash. So you say Q is false. That means it will be false, right? If P is false and Q is true, Q is false. If P is false and Q is also false. So we know that this is backwards true, right? P is false, Q is false. So P implies Q. That means if P is false, then Q is also false. The statement will be true, okay? Do you remember?
Wait. If P is true and Q is false,
then P implies Q will be false. And if P is false and Q is false, so P implies Q will be true, right? The backwards true.
I got it for the second, but the first I forget.
Yeah, the first one, if Q is false, so result will be false. If Q is true, so result will be true, okay? This way. Now let's see here. Dash reflects the average amount of information provided by each information sent by the source. It is called information entropy, okay? Information entropy. So what is the information entropy definition? Information entropy reflects the average amount of information provided by each information sent by the source. So the answer will be information entropy. Number 8, in BP learning algorithm. So BP means maybe blood pressure, I'm not sure. So in BP learning algorithm, forward propagation is the normal propagation of the value input signal from the dash layer to the dash layer, through the dash layer to the dash layer. So from the input layer, from the input layer through the hidden layer and to the output layer, okay? So you can assume this as a tunnel, okay, as a tunnel. So if there is a train is going into the tunnel, okay? So you can see this train, it is going into the tunnel. So input layer, okay? This is the input. And through the hidden layer, that means this tunnel is hidden. This tunnel is hidden, right? So input layer, then the hidden layer, that is tunnel, and then it is output, right? The output layer. So is this clear?
Yes.
But for AI, so we got this way, like we got some input, then we do some calculation here. We have some hidden layer here, okay? It can be multiple layer. It can be multiple layer, okay? And then we get some output. So this is called input layer, hidden layer, and output layer. Okay.
Okay, Omar.
And then number 9. We don't have number 9, just we have true false. So let's
false.
discuss true false. Yeah. Multi-layer neural network is a network structure with one or more hidden layers embedded between input layer and the output layer. Yeah, so we have multi-layer neural network, right? So we can have one or more hidden layers embedded between the input and output layer. So this is true. And then the second one. Depth first search algorithm and width search algorithm. We can also say this as breadth first, breadth and depth. So depth first search algorithm and width search algorithm belong to heuristic search strategy. So this is false. Okay, this is false. This doesn't belong to heuristic search strategy. Okay. Fourth one, machine learning is a subject that studies how computers simulate human learning activities and automatically acquire knowledge. Yeah, that's true. This is machine learning. Yep. Okay. It studies how computers simulate human learning activities and automatically acquire knowledge. And for 5, the semiotic school of artificial intelligence believes that artificial intelligence originates from cybernetics. That is false, okay? Cybernetics originated from where? Still remember? Behaviorism, right? So cybernetics originated from behaviorism. It doesn't come from artificial intelligence, okay? The compound formula has properties P implies Q is equivalent to not Q implies P. So this is false, okay? I mentioned this in my logic notes. If P implies Q, then not Q implies P. This is not equivalent. Okay? They are not equivalent, okay? So the answer will be false. Forward propagation network essentially represents a mapping from input space to output space. Okay, so forward propagation. So it is true maybe. Yeah, it is true, okay? And 8 is the regression method of a state space includes 3 elements. 3 elements: a state, operator, and a state space. The representation method of a state space includes 3 elements. First a state, and then operator, and then the third one is state space. So this is also true. And the formula formed by connecting several formulas with this conjunction is called disjunction. This is false. Yeah, this is not disjunction. This is conjunction. And then number 10, A star algorithm and A algorithm belong to blind search strategy. This is also false. Okay, Chris, do you understand?
I got it, Amar.
So we have Hassan is still here or not? Yeah, Hassan is here. Hassan, do you understand, bro? Yeah, BP means blood pressure, I think. Yeah, I'm not sure. Maybe.
BP means back propagation.
Back progression, right?
Back propagation.
Back propagation. Okay, I'm not sure. Let me start. Back to the blood
Yeah,
pressure.
we call blood pressure.
Okay, back propagation. Yeah, maybe. You know, sometimes when you go for blood test, so they say BP test. So back propagation, okay. Back propagation is just a way of propagating the local loss, the total loss back into the neural network to know how much of the loss every node is responsible for, and subsequently updating the weights in such a way that minimize the loss by giving the nodes with higher error rates, lower weights, and vice versa. Okay. So okay, so this is back propagation.
Oh, don't you remember we submitted homework too, and we talk about back propagation?
Yep.
Yeah, I think yes.
Okay.
But when I was trying to review these screenshots, I thought that this is like a blood pressure algorithm, because maybe in future we can also design some algorithm to find the blood pressure, to find I mean everything. Okay, but yeah, it
Okay,
seems
so
to be
Omar,
hard.
we have complete the sample question, right?
Maybe we have more.
Right? Oh, really? Oh,
Yeah,
but also,
you see the same. I mean the concepts are pretty much similar. You see the homework tree. We also have to find the decision tree. So
yep.
you can have a look here in my notes in my homework. So you will see that how I came up with the solution. You can just understand them. Okay. Maybe I already explained them.
Like we have discussed before, right?
Yeah, right. You see, information gain, it is equal entropy minus conditional entropy. So here our conditional, here information gain, this one is bigger. So we write down here in the root node. So we again split. So before we have on and two, but now we have long and short, right? So we can have any other condition. We don't care, just the similar. So okay, and then track. So here is another. Maybe I need to explain this one for in a very quickly. Okay, this one.
Yep.
Suppose the ratio of the number of trucks and buses passing on a road B2:1. So suppose the ratio of the number of trucks and buses passing on the road is 2:1. Okay. So we have in total 2 plus 1, that is 3. And the probability of a truck stopping for repairs is 0.02 and bus is 0.01. So now we have to see how many objects we have here. Firstly, we have a total 2 plus 1, 3. And then we have truck and buses, right? Truck and buses. And we have their probability of stopping for repairs. So first one for bus, that is 0.02, and sorry, for truck that is 0.02, and bus that is 0.01. Okay, so remember that you don't mix up those things. So just a ratio of number of trucks and buses. So the first one is truck. You can also take a rough note, and it is truck. And the second one, this is bus, right? Okay. And the probability of truck stopping for repairs is 0.02. This is truck, and this is bus. So now there is a car stopping for repairs. Find the probability that the car is a truck. So we have to find this is a truck, and the car is a truck, and also it needs repair. Okay. So the condition will be a repair, and then it should be a truck. So let's symbolize them. First, let's say that B means it needs repair. Okay. You can also let R. I mean that's more reasonable to think, right? So let's say B is the car need to be repaired, and A1 is truck, and A2 is bus. So the B means this car can either be a truck or bus, so we don't care, but it needs repair. So we just use the union sign because you have to add them together, right? So the first one, the probability that this is a truck, and then multiplied with the probability that this needs repair. Okay, then union means plus, and then A2 means this is a bus, and times this need repair. Okay, so 2 plus 1 we have 3, so probability of A1. So if this is a probability that this is a truck, so we have 3 out of 2. 3 out of 2 is truck, right? So P of A1 is 2 by 3. And then probability of A2, that means this is a bus. It will be 3 out of 1. So we know that 3 out of 1, they are bus. And now this probability that the car needs repair. So B is here, repair. And this car have to be a truck. So the condition is truck. Okay, this is the condition. This is the condition. So how do we find this one, 0.02? It's already given. Okay, it's already given that you see here the probability of a truck stopping for repair is 0.02. So it needs repair, and then it is a truck. So it is already given here. You need to write down the notation. So probability of it needs repair, and condition is it is a truck. Okay, A1. Right? Okay. So it's already given, and then probability of this needs repair, and this is a bus. Okay, it is also given 0.01. Now we have to find what now there is a car stopping for repairs. Find the probability that the car is a truck. So you have to find the probability that this is a truck. And then, so you see here, the car is a truck, right? A1 is a truck. Car is a truck, but here the condition is it needs repair. Okay, you see, different from before. Previously we had it needs repair and it's a truck, but now we have it's a truck, and the condition is it needs to be repaired. Okay. So if you look the final question here, find the probability that the car is a truck. So the final question here is it should be a truck. So truck means probability that it should be a truck. So we start from A1. Okay, A1, it's a truck. And condition, the condition is this needs repair. Okay. So you see these two have some difference, right? This one and this one, they have some difference. So you have to understand them by reading the question. And now let's see how can we find them. So this is also a conditional entropy. So what we do here, according to the formula, on the upper side, we write down probability of A1 intersection B. Okay, and then we divide by the condition. So here condition is B. So probability of A1 intersection B, and then divided by the probability of B. Now let's find how do we count probability of A1 intersection B. So you see probability of A1, if this is a truck, so we have 2 trucks, right? Out of 3 there is 2 trucks. You see here 2 trucks. We write down 2, and then probability of repair. So probability of B, that is not calculated. That is probability of B, right? That is calculated here, right? The car needs to be repaired, and this is a truck. So this is 0.02. So we multiply them. Okay, so we get 0.04. And then probability of B, that means probability of it can be a truck or car, but it needs to be repaired. Okay, so it will be A on B union A to B, because A on B means a truck needs to be repaired, then plus A to B means the car needs to be repaired. So now we can write down a plus sign instead of union. So we already got A on B, that is 0.04. And for A to B, you can also find A to B. So for buses, we have only 3 out of on bus, right? You can see here we have 3 out of on bus. So 1 times the probability that the bus needs to be repaired, that is 0.01. We multiply 0.01, okay? So we get the answer 0.01 as A to B. So if I substitute the value here I substitute the value, okay? And then here I substitute the value. So I got the answer, probability of B, that is 0.05. So here is 0.05. So 0.04 divided by 0.05, that is 0.8. Okay? Maybe our teacher explained this in the previous class, right?
Yeah.
I just got some screenshot from Idris, okay? He gave me some screenshot and I had to understand from there because I had no other option. I missed the class, so I understand the solution from just this part, okay? But the last part here, it's really hard to understand, but I tried to explain it in a simpler way. In a simpler way here, right? You can see here. So I had to analyze like how this solution was given, and then I had to go back to the formula that I know, and then I had to come up with a solution, right? So it was really hard for me to just write down this part, the last part. Okay. Maybe it seems very easy, like, yeah, this is the answer, but firstly I had to understand from here, so what they calculated, and then the last line I got some problem, and then I searched on YouTube, I searched on Google, and finally I get some idea like how can we understand them. So this is the answer. And let's we have something more. It was the first decision tree that our teacher explained. I think you can understand this one, right? We had to find the watermelon. Watermelon is good condition of watermelon. So it's the same as before. We have some attribute and we have some condition. So we find the information gain. You see here, lousy calculated information gain. Then the information gain is bigger when this is color. When the attribute is color, then the information gain is bigger. So we start from the color. You see here, we start from the color, and then we split by the condition. It is dark green and it is plain. So if it is dark green, so we only get the good watermelons. And if it's plain, so we start another attribute that is knocking. I mean the second attribute here. So again, we split the condition, if it is muddy or if it is dull. So if it's muddy, it's bad. If it is dull, then it's good. So this way, the similar thing that I explained just now is the same, okay?
Okay.
So I think that's all maybe for the everything.
For our study. For our preparation for this exam.
Yeah, you're right. So thank you for joining. Maybe
Omar,
I'll try to, yeah, right.
When you go to China?
I got a phone call from the embassy, okay? So they told me that I have to inform my university to mail them the original JW. So maybe original JW, they will arrive in this week. Our seniors already told. So if I get visa within 2 weeks, so I will try to buy ticket, and maybe next month and the end of
in the middle
month,
of November.
I am not sure. It depends on the flight, okay? Because we are expecting we're expecting chartered flight.